Hello everyone. In this video, we will dive deep into the Remix IDE and smart contracts. My name is Kanishk and let's get started with what is Remix IDE. Remix IDE is a web-based development environment that allows developers to write, test, and deploy smart contracts on Ethereum and other EVM-compatible blockchains. It was built to support Solidity, the primary language for writing smart contracts on Ethereum. Remix IDE is a part of large Remix project which consists of several tools for Solidity development, including Remix plugins, Remix libraries, and Remix testing modules. Since Remix is entirely web-based, we can access it directly via our browser without needing to download or install any software. Alternatively, it also supports a local desktop version for those who prefer offline development. Now, let's look at its features. First one is Solidity Compiler. Remix has an integrated Solidity compiler which is continuously updated to support new Solidity versions. This allows developers to compile and test contracts directly within the environment, avoiding manual compilation steps. Contract development and interaction. Remix provides a user-friendly interface for deploying and interacting with smart contracts. We can easily deploy contracts on our local blockchain using a tool like Ganache or connect to a test network like Ropsten and Guerli and even deploy on Ethereum mainnet. Debugger. Remix built-in debugger helps track down issues within our smart contracts. This allows us to debug transactions reverts, step through the execution of contract and view the contract state at different point of transaction. Static analysis. The IDE includes static analysis tools that performs a range of checks on our code to detect common vulnerabilities and logical errors before deploying contracts. This is vital for ensuring that our smart contract is secure and optimized. File management. Remix provides an easy-to-use file explorer where we can manage our project files, create new Solidity files, and store contract artifacts. Remix plugin system. The Remix plugin system allows developers to extend IDE's functionalities. We can install various plugins for linting, testing, and even for integration with external blockchain tools. For example, we can connect Remix to Truffle or Hardhat to expand our workflow. Now, let's start with a demonstration of Remix IDE. We can access Remix IDE by navigating to the official website at https://remix.ethereum.org. Alternatively, we can download the desktop version of Remix, but for this video, we will use the online version. Once we have opened Remix, we'll notice the workspace layout consists of three main areas. File Explorer, located on the left-hand side, this panel allows us to create, delete, and manage Solidity files and folders. Editor, the center area is where we write our Solidity code. Terminal. At the bottom, the terminal displays compilation outputs, transaction logs, and error messages. To start, we create a new Solidity file by clicking on Create New File button in the File Explorer and naming it a .sol extension. We will write a basic code in our file in which we will store hello world in a variable and print it. Also, we can change the value of our variable once our contract is deployed. This contains a public string variable, greet, which stores the message hello world by default. The setGreet functions allows users to change the greeting. Click on Solidity Compiler tab on the left side of the screen. Select the appropriate compiler version, which should match the version declared in our Solidity. Then click on Compile File.sol button to compile the contract. Switch to Deploy and Run Transaction tab and we will see options to deploy the compiled contract. We can deploy this contract in many environments, but for this demo, we will keep it as default. Once deployed, the contract will appear under the Deployed Contract section. We can interact with it directly from our Remix UI. Expand the deployed contract and we can see the greet variable and the setGreet function. We can call these functions to view and modify the greeting. Here are some tips for maximizing Remix IDE. Version compatibility. Always ensure that the compiler version matches the Solidity code to avoid compilation errors. Plugins for enhanced productivity. Install essential plugins like Solidity Static Analysis to catch security vulnerabilities early and Solidity Unit Testing for automated testing. Use external libraries. Remix allows us to import Solidity libraries such as OpenZeppelin directly into our project. Simply use import statement in our contract and manage dependencies easily. Network connections. When deploying to a test network or the mainnet, always double check configuration and ensure that we are connected to the right blockchain network. For those new to the blockchain development, Remix is a great stepping stone to understand the basic of smart contracts development and deployment. Once we are comfortable with Remix, we can explore more advanced workflows using tools like Truffle or Hardhat. In evolving landscape of blockchain technology, smart contracts are one of the most impactful innovations. What are exactly a smart contract and why are they so important? Smart contract is a self-executing contract with the term of agreement directly written into lines of code. These contracts run on blockchain networks, most commonly Ethereum, which allows them to execute transactions and agreements automatically once predefined conditions are met. Smart contracts operate independently and are tamper-proof, meaning that once they are deployed on blockchain, they cannot be altered by any party. This makes them highly secure and transparent, as the entire network execution is visible to all the participants in the network. In simple terms, a smart contract is like a digital if-then statement. For example, if person A sends 5 ethers to person B, then the contract releases the ownership of asset to person A. Let's see how smart contract works. Smart contracts works by answering a pre-programmed rule and condition which are enabled in the contract code. When the conditions are met, the contract executes itself automatically. Here's a step-by-step breakdown of how smart contracts operate. Creation. A developer writes the smart contract using a programming language, for example Solidity on Ethereum. The contract contains the logic that defines what should happen when certain event occurs. Deployment. Once the contract code is complete, it is deployed to the blockchain. The contract is now part of blockchain's immutable ledger, ensuring that it cannot be changed. Execution. When participants meet the terms defined in the contract, it is triggered to execute. The blockchain network verifies the conditions, and once confirmed, the contract performs its actions, such as transferring funds, releasing ownership, etc. Completion. After execution, the outcome is recorded on the blockchain. The contract has fulfilled its obligations and the transaction is completed. Since smart contracts are executed on blockchain, they are decentralized, meaning there is no need of a third-party intermediary such as bank or lawyer to enforce the terms. This saves times, reduces costs, and enhances trust between parties. That's it for this video. Thanks for watching.